Hello, my name is Soda Samia Shane and my student ID is 4087523. Now we are going to do an analysis of the file provided. That is, first we go to the statistics and capture file properties, and we can see that we have 2,431 files over the span of 22 seconds, which is a large number of files for a very short amount of time. So we need to look into that first, and then we got protocol hierarchy, and we can see that it's mostly everything's TCP and HTTP sits on top of it. No DNS or other noises, so this is a focused web layer conversation. Now we check the conversation for the file, and we see that there are two main hosts, which are one client hammering one server. That's a red flag on its own, and now two hosts in the whole file are sending like big files to one another. And then we move to TCP, and we can see that 209 separate connections between the same two hosts in 2 seconds of time. 22 seconds points out the burst pattern you noticed, and you can see that there's like gap and then another burst comes along. So that is also a red flag. And then moving on, we do the HTTP request filter. And when we do the request filter, we can see that 219 requests all get or post to the same slash that which indicates that it's not a normal browsing, because so many requests with slash over a short period of time usually means it's not a human user and a machine doing all the work. And then we integrate the user agent column. We apply this as a column, and we can see that the same fabricated identities, like Google Pocket is not a real thing. And we can see that there's only 7 user agent strings repeating over and over, some of them fake, malformed, and this is evasion, not real browsing diversity. And we can see that it's been repeatedly used over and over again. To dive deeper, we go into the IO graph, and it is based on the HTTP request. We can see that 10 requests per second sustain the whole capture. No lol, that's a sign of an automated tool, not a person. So throughout, we've got several signs that these are not human interactions and human activities, and moreover, automated tool trying to attack. So following now we go into the request packet, and then we click into anyone, and we follow the TCP stream. We can see that the client has made what can we say? Client says keep alive, server offers keep alive, but the connection almost immediately dies down just after one request anyway. That mismatch burns severe resources needlessly. So that is also another finding. And then we apply the SYN filter to check for SYN attacks, and for that we need to apply tcp.flags.sin equal 1, and we reach this folder, and here we can see that 209 SYNs, and we can see that they were all answered with SYN SEKs and 0 resets. So it's not a SYN flood, it's full legitimate looking connections being abused. So we can rule that one out. And lastly, we use the http.response filter, which shows us that how did the server respond. So every single request got a 200 OK response. The server was still up and coping. So this shows that attack is still in progress and it's not over yet. So what we can conclude in this is that we have diagnosed an HTTP GET or POST flood, a layer 7 or denial of service attack based on the connection volume, repeated single URI request, user agent rotations, and keep alive mismatch. So, yep, that's the findings for the whole. Thank you.